Good morning everyone. So today's lesson we're going to be actually practicing algebraic proof. The first thing we'd like us to do is match these statements to these algebraic expressions. I have also emailed you a worksheet for you, so if you wanted to, you could potentially cut them out and match them together like that, or feel free to pause the video and try it. So I'm not going to go through the answers. So any even number can be written as 2n. The reason as to why is that is because if you multiply anything by 2, it automatically becomes an even number. So therefore, any odd number can be written as 2n plus 1. These are the two main things you're actually going to be using throughout this process. That an even number is 2n, and that odd number can be written as 2n plus 1. So you'll be asked to either prove or show that, and this is when you know you're going to be using proof. So start the statement on the right hand side. Okay, so that RHS stands for right hand side. A lot of the time I actually don't even use the right hand side. I do everything on the left hand side, and then I see if I can actually get to that answer. So let's see what this actually stands for. Now, can you please try and do these questions for us? I've got the answers here, so it's quite easy for you to check how you're doing. So it says prove that this is equal to that. So the way for you to actually do it, I'm expecting you to, in your books, be expanding your double brackets, and then taking away this. Now, please be careful. So when you expand the first one, you've got to get n squared plus 16 plus 8n. Take away 3n plus 4. Now, so therefore, it's going to be n squared plus 16 plus 8n. Take 3n, take 4. So therefore, you're left with n squared plus 5n plus 12. This is what I've got. So have they gone from that to this? So you can either see if you could potentially factorize, or let's see if we can actually expand it. Can you? So these are questions. So let's expand n squared plus 1 n plus 4 plus 8. So therefore this will be n squared plus n plus 4n plus 4 plus 8 n squared plus 5n plus 12. Both equal to each other. Done. So this is how I can actually prove it. So I've not moved everything to the left hand side, I've not moved everything to the right hand side, but I have solved the left, I have solved the right, and I've proved that they're both equal to each other. This is what we'd like us to do for the rest of these questions. So pause the video, try these questions. Obviously solutions are always on the right hand side. If your left hand side is equal to the right hand side, you have proved it. So as I said previously, okay, we're going to be using 2n is an even number. 2n plus 1 is an odd number. The other one they actually like using is the word consecutive. So consecutive, what does consecutive mean? Well, consecutive means one after the other. So what if I wanted consecutive even numbers? Well, the first one would be 2n, the next one would be 2n plus 2, the next would be 2n plus 4, and so on. What if I needed consecutive odd numbers? 2n plus 1, 2n plus 3, 2n plus 5. Okay, so this is all you're going to be using. Other words that they like using, okay, they like using the word product. Okay, so you know product stands for multiply. So product will be multiply. So you might here's an expression, here's the other one. What's the product of them? They like using the difference of squares. So difference of squares. So it means you're going to have two expressions that are squared, and then subtracting in between for them. So let's have a look at a question. So prove that the difference between the squares, okay, exactly what I said earlier. Prove that the difference between the squares of any two consecutive even numbers is always a multiple of 4. So feel free to pause the video here, try the question, and I'm going to go through the answer now. So two consecutive even numbers. So even is 2n. I want consecutive, okay, so therefore the other even number must be 2n plus 2. So prove the difference between the squares. Okay, so I want the difference between these two numbers. So obviously this is the larger number. So there's something that I've not used yet. It says squares. So therefore, squared. If I expand the first one, I get 4n squared plus 4 plus 8n. Subtract 4n squared. So 4n squared plus 4n plus 8n, take 4n squared. So I'm left with 8 plus 8n, plus 4. Now, how is this a multiple of 4? But at this stage here, I need to actually think of factorising. 4, 2n plus 1. Well, anything that is a multiple of 4 is going to be, anything you can multiply by 4 is going to be a multiple of 4. So this is how you'd prove a question like this. A bit more complicated to begin with, okay? But now I want a multiple of 6. So multiple of 6 we need. So let's start with the question. So expanding. 3n squared, 3n plus 1 squared, subtract 3n, take 1 squared. If I expand these, I'm going to get 9n squared plus 1 plus 6n, subtract 9n squared plus 1, take 6n. Okay, please note that I've actually got brackets on the second one. This is where the difficulty comes with prof questions, okay? Making a mistake with the signs. So let's expand. 9n squared plus 1 plus 6n, take away 9n squared, take away 1 plus 6n. These two cancel each other out. These two cancel each other out. So I'm simply left with 12n. Now, how is this a multiple of 6? Well, 6 times 2n. So this is how you would actually say that is a multiple of 6. Next question, the product of two consecutive positive integers is added to the larger one of the two integers. Prove the result is always a square number. So again, pause your video and see how you can actually start this question. So let's take two integers. So say for the first one is 2n, and the other one is going to be 2n plus 1. So the product of the two consecutive positive integers, so this is the product, is added to the larger of the two integers. This is the largest one, obviously, because I've added 1. So let's expand. 4n squared plus 2n plus 2n plus 1. Simplify. Now, could I possibly factorise this? Yes, I could factorise, and it's going to be 2n plus 1 all squared. Well, isn't that always a positive number? Yes, it is. So positive and square number. So that is how you would actually prove this question. So I've also emailed you a worksheet for you to actually complete. Feel free to do the support, the core, or the extension work for us. Again, you can check that you've done it right by simply proving it. If you've proved that that's a multiple of 6 and you've got 7 times something, obviously you've not proved it. So some extension work for us. After you finish with that work, you can actually try these questions. So it says prove that n plus 1 squared, take away n, take 1 squared, plus 4 is always an even number. So feel free to pause, and then I'm going to go through the answer. So again, I'm starting with expanding. N squared plus 1 plus 2n, take away n squared, take 2n plus 1 plus 4. So n squared plus 1 plus 2n, take away n squared plus 2n, take away 1 plus 4. So we can actually simplify, cancels down, cancels, so I'm left with 4n plus 4 is always an even number I want, so therefore 4 lots of n plus 1. Anything multiplied by 4 will be an even number, therefore always even. And the next question, prove algebraically that the difference between the squares of any two consecutive numbers is always an odd number. So prove the difference between the squares of any two consecutive numbers is always an odd number. So again, pause your video, and I'm going to go to the answer now. So 2 consecutive numbers, let's take 2n, and again 2n plus 1. Difference between the squares of any 2 consecutive numbers is always an odd number. So take them away. Four n squared plus 2n plus 4n even plus 1, take away 4n squared. Cancels. 4n squared plus 4n plus 1. Well, therefore, this will always be odd, as 4n is always even, because we're simply adding 1 to it. Thank you very much.